How are you? I feel all better. Welcome to our YouTube channel KRIDHU. Today we are going to read reducible to linear differential equation, which is also known as Bernoulli's equation. It is the most important topic of M2 from Unit 1st. It is fixed question for the same purpose also and for the mid purpose also. Bernoulli's equation. So focus over this, and if you not gone through our previous video, then I'll keep the link of that. You can go through it. I'll keep link in description box. You can go through it. The Bernoulli's equation is in the form of dy over dx plus py equal to q dot yn. It is almost equal to our normal linear differential equation. Remember this. Here just the change you can observe is by power n in this form. Other nothing changed here, all equal to the linear differential equation. So dy over dx means what? Normal, like previously I said. You go through previous video means you will understand, but I'm telling here also. Dy over dx means y is the first order differentiation with respect to x plus py equal to q dot yn. Here p and q represent either it will be a constant or it may be a function of x, but it should not be a function of y. Remember this point. This is much important point. Next here we are observing that is by n. So here n value should not equal to 0 comma 1, because if n equal to 0 means by power 0 means 1. That is equal to dy over dx plus py equal to q, which we also known as linear differential equation. Okay, remember this point. And if we kept 1 also, then also it will be equal to linear differential equation. So it should not be equal to this too. Okay, we'll check how to solve the Bernoulli's equation. Okay, as here by power n added is most like additionally to the linear differential equation. So here somewhat solving procedure also changing. So focus over this. Okay, so step one is you have to divide the equation by power n, because in Qn by power n is there. So hold the equation first, dividing by power n. So here what coming? 1 by y power n dy over dx. Okay, this coming. Here p y n minus 1 y came means already y is there. Now we are dividing by power n. So upside y is downside written as y power minus 1. Y power minus 1 divided by yn. This we can write as p over y power n minus 1 equal to q. This is our equation number 2. Okay, remember this. Now again here we have to use what? Substitution method. Like previously I said, here we are using what? Substitution of differentiation, not the substitution method of integration. Okay, so focus on this. So first step what we doing? We are taking 1 over y n minus 1 equal to v, and that we telling us equation number 3. Okay, this is first thing we're doing. Now what we're doing? We are differentiating this term 1 over yn minus 1. This term we differentiating with respect to x. So what we getting? Minus n minus 1 over yn dy over dx equal to dv over dx. This term will get if we differentiating with respect to x, both the side. Then this thing we get. Okay, remember this. So what we'll do? Now we'll cross multiply here. This both will cross multiply. Then what we'll get? We'll get the this 1 over yn dy over dx, because from this side one thing coming that other side, and just we cross multiplying. Remember this. After cross multiplying, the equation number 4 that we getting is this. Cross multiplication is nothing but this minus n minus 1 is send it to other side. That's it. It's our cross multiplication. Okay, so that we keeping as equation number 4. Now what we doing? We putting equation number 3 and 4, these two equations. We putting in the equation number 2, this equation. So what we getting now? 1 over yn dy over dx is equal to minus 1 over n minus 1 dv over dx from the equation number 4. This we written from the equation number 4. Okay, plus b dot p. B dot p means how? 1 over yn minus 1 equal to b from equation number 3rd we taken. So we written here equal to q. Now what we have to do? Now we have to divide equation by minus n minus 1. Means we are removing the coefficient of dv over dx and making it 1 as per the linear differential equation method. Okay, as per the linear differential equation method. Here you see step 2 dv over dx coefficient equal to 1. So after dividing it means what we get in dy over dx minus n minus 1 p. Why minus n minus 1 p? So this is because normally while we dividing it now, so b dot p, it is taking it upside equal to, here it is in division, sorry, here it is not divide, here it will be multiply because it is already in divide now, so we have to multiply so that it will value will go, so we multiplying it, that's it, coming minus n minus 1 p equal to minus n minus 1 q. That is our linear differential equation. Okay, remember this point. This is our linear differential equation. This last equation that we shown, that is this equation is linear differential equation. As per previous equation, what we understood, that we got a linear differential equation. So linear differential equation, how we have to solve it? So step 3, we following as per the linear differential equation, we finding integrating factor if. So what is the formula of if for the format 1? If equal to exponential power integral e dx. So that we writing here. Next step 4, it is also equal to format 1 linear differential equation is b into if equal to integral q into if dx. Here integrating q into if with respect to dx and b into if only. Here y is changing with the y b. That's it. This b equal to y for the format 1. Other all things are same. Remember this thing. Now we are going to see a problem based on the linear differential equation. I mean Bernoulli's equation. This is the problem based on the Bernoulli's equation. This is one of the most important problem. That's why I'm taking it. So go through it. Okay, properly focus over it and watch video up to last. Okay. So question is x dy over dx plus y equal to y square log x. This is the equation we got. Now first step, what was whatever the value we getting in this quotient side, I mean this side, q side, that we have to divide. So divide our equation by the x by square. First point what we're doing is divide the equation first by x by square. So while we're dividing this equation number 1 by x by square means what we getting? We getting here 1 by y square dy over dx, because here already one x sum was available. So this is 1 by y square dy over dx plus y over x by square, because we are dividing by x by square, log x over x. This is the simple what we getting equation. This we calling equation number something we can a. Okay, now 1 by y square dy over dx plus 1 over x by, because by y got by in the square got cut, 1 over x by equal to log x over x. This is we taking as equation number 1. Equation number 1. Now we using substitution method of differentiation. So here we taking 1 by y as b, that is equation number second be taken. Okay, now differentiating 1 over y with respect to dx. So what we getting? Minus 1 by y square dy over dx equal to dv over dx. This we got. Okay, so now we cross multiplying it here. So what we getting? This minus symbol is sending to dv over dx side. So 1 by y square dv over dx. I mean this minus 1 by y square term is sent to, this is y here. Okay, this what we're writing is 1 over y square dy over dx equal to minus db over dx. That is be taken equation number 3. This is y here, sorry, 1 by y square dy here, okay, dy over dx. Now equation number second and third, these two we have to put in equation number first, this one. Now after keeping the value of equation number second and third and first, what we getting minus db over dx plus 1 by xb equal to log x over x. This is what we got. Now multiply by minus in whole the equation to make the dv over dx a positive 1 coefficient. So dv over dx minus v over x, because minus we multiplied, so plus became minus, equal to minus log x over x. This is a linear differential equation and we consider as equation number 4. This is a linear differential equation, remember this point. So for the linear differential equation solution, we have to find the integrating factor. So integrating factor formula for this format one is if equal to exponential power integral p dx. So here p is what? Minus 1 by x. So e power minus 1 by x dx. Now you know is only, I think so, integral 1 by x formula, integral 1 by x equal to log x we given. So here if equal to e minus log x. Now e and log x will cut each other. So here if equal to 1 by x came. Okay. Now the final step of the solving of linear differential equation is finding the solution. So solution of equation number 4 is b into if equal to integral in bracket q into if with respect to dx. Okay, this is our solution, basic equation. For the solution, basic equation is this. Okay, so now we are keeping if value, so b into 1 by x, this is if value, equal to minus log x over x, this is q value, into 1 by x dx. Okay, now again here we have what we have to use, substitution method of integration. So log x we consider as t, so 1 by x dx, we differentiated log x with dx, so 1 by x dx equal to dt. Okay, now log x we consider as t means x equal to et, because log, if other side going means it is becoming exponential. Okay, this is basic thing. So now we can keeping this both substitution in this equation, in this. Okay, so what we getting, b over x equal to minus integral t over et dt. Okay, this is what we getting equation, what we got. So now as we know the formula of minus, not minus, like normal integral x e power x dx is we getting e power t in bracket t e power x in bracket x minus 1 plus c. That formula we applying here. That formula I also said in previous video. If you want to see means you can go to previous video, link will be in description. Okay, don't forget it. So by x over equal to e power minus t in bracket t plus 1 plus c. This is by that formula. Okay, because here minus is in front, so all the symbols are changing. Okay, so lastly now what we have to do, we have to substitute b by the 1 by y. So 1 by y x and t with the log x, so e power minus log x plus 1 plus c. This is what we got in this formula I was talking, that is this. My formula what I was talking, this is this. Okay, this formula we applied. Now we substituting values and we getting the final solution. This is only our answer. So like, subscribe, comment, share for more updates.